Hi, my name is Vasha DuTell. I'm a postdoctoral scholar in the METEOR program here at CSAIL. I am co-advised by Ruth Rosenholtz and Bill Freeman in the Visual Computing Group, and I'm interested in understanding the relationship between human vision and computer vision, specifically how computer vision systems process information in time and how that we can use those tools in order to better understand the human visual system, and in addition, using what we know about the human visual system to make biologically inspired computer vision models to better process information in time and videos. Yeah, I have a couple different projects. One of the main projects I've been working on is understanding some of these models of peripheral vision. So how our vision is different in the central area of our vision versus how we see things in the periphery. And this is super important for many different tasks. I think many people commonly think that we only use our central vision, but actually the peripheral vision, our vision to the sides, is really, really important. It's super important in sports, in driving. It's super important to be able to see motion, to make sure you see a pedestrian, a stop sign, this kind of thing. We've been working on a model to both improve models that we have of peripheral vision processing and also extend those into time. So currently most of the models for human peripheral vision processing are only for images, for like one snapshot in time. But we want to see how can we improve those models so they change over time, like humans actually do process motion. Often when people have looked at this in the past, they'll just kind of do a little bit of blur on the edge of the image or something in order to represent the loss of information in peripheral vision, but we actually believe that peripheral vision is a lot more complicated than that. It's not just a simple blurring mechanism. So in our lab, we have a model that processes the images in a peripheral processing way similar to that of the human visual system, and it allows us to produce images that are a little bit different than the original image. So we can take an image, we put it through our processing system, and then we get an image that's been altered in a way that represents the same statistics that the human would have seen. So we call these mongrels or metamers. They're really useful in order to feed to the computer vision system. So the computer vision system has not the original full image, but the same information that the human visual system would have. And so we're hoping that these sort of processed images might be helpful for training computer vision systems in order to make them more robust. Some areas of application I think would be, for example, driving. That would be a great one where you want to make sure your driver can see the really important things on the road that they need to, like a stop sign or a pedestrian, cyclist, which might be moving fast. Also, in general, in user interface design, right? If you want to design something that's going to work well for a human, you want to understand what they can see and what they can't. Video compression can be one. If you want to understand what humans see and what they don't, you could potentially throw away more information and keep only what's necessary. I think one common misconception about computer vision is that it's very limited to certain areas. I think people often think, oh, computer vision, that's like self-driving cars, right? Especially when I talk about driving. But actually, it's so much more than that. I think often people look at computer vision as just something as an engineering problem, right? I'm going to design my neural network in order to better detect humans in a scene or segment the scene, identify different objects. But I think what's really cool about this area of combining computer vision and what we know about deep learning and neural networks with human vision is that we can actually use those computer vision tools to better understand the human vision side of things. So we can use this as a tool to better understand how and why our visual system acts the way that it does, and how we keep information, throw away different information, how we keep what's important for our day-to-day lives. Yeah, the METEOR program's been really great. It's really wonderful to be here at CSAIL, first of all. When I thought about my options after my PhD, I didn't really consider that MIT CSAIL would be an option for me. I don't know, I guess, think enough of myself to think that I could be here, but I was absolutely able to. And so I'm super grateful to this fellowship for allowing me to do that. But I would also really encourage other people towards the end of their PhDs, if they think that what's going on here at MIT is interesting, definitely throw your hat in the ring and give it a go. And you might find yourself here.